As we all know, there's a limited amount of resources and hours of work that can be done in the world, and in order to maximize the efficiency in which the world is able to operate, countries will trade with each other. Countries won't just trade to trade, though, because sometimes trading isn't beneficial for both countries. But how do we know if trading is beneficial? Well, comparative advantages help to explain when trading will benefit both countries, even if on the surface it looks like one country is better at making both items involved in a trade. Let's take two real-life scenarios. In the first, Brennan and Matt both produce international space stations and bags of animal cookies in the same period of time with the same resources. This is called an output problem. So, let's say, given 5 minutes, Brennan can make, well, with his superior math skills, a grand total of 72 ISSs. That's impressive. However, Brennan is no baker, so he can only make 24 bags of animal cookies. Although, they are still pretty good, but there's only 24 of them. Now, Matt, on the other hand, he's only in linear algebra, so he can only make, well, 16 ISSs in 5 minutes. But hey, that's still pretty impressive. You go, Matt. But Matt is an award-winning baker, although he's a slow one, so he can only produce 4 bags of animal cookies, but they are really good. This is an output problem because given 5 minutes, Brennan and Matt can both make ISSs or bags of animal cookies using the same number of resources. So now, let's just fill in the numbers. First of all, I can make, well, 72 ISSs in 5 minutes, so I'll just write that, 72. And I can make 24 bags of animal cookies. Now, what's important to note is I can only make either one of those things, or technically I could also make a combination of the two, but I could either make 72 ISSs or 24 bags of animal cookies. And now Matt, well, he can only make 16 ISSs, but he's trying his best, or he can make 4 bags of animal cookies. Now, here's what we want to do. First, let's determine who has the absolute advantage. Now, absolute advantage is just who can make the most of one thing. Well, for ISSs, that's definitely me, because 72 is a little bit more than 16, so it means I have the absolute advantage in ISSs. Now, if we look at the bags of animal cookies, I can produce 24 and he can only produce 4, so that means I also have the absolute advantage. So, for this problem, I have the absolute advantage for both different products. Now, what do we want to do next? Well, let's find the comparative advantage to see if we should trade or not. Right, so, first, well, let's find, if we make one ISS, how many different bags of animal cookies could we have made, or in other words, what's the opportunity cost of, well, one ISS, right? What's the opportunity cost in the bags of animal cookies? So, to do that, well, you just divide. So, we take this number right here, and we just put that over the top number, and 24 divided by 72 is 1/3. So, that means for every ISS we produce, we could have produced 1/3 of a bag of animal cookies. So, I'll write that. That's my opportunity cost. That is 1/3. Now, I just do the same thing for the other side. I just take the other number and put it on top, and then divide. So, if I want to make one bag of animal cookies, I could have made, well, 72 divided by 24 is 3. So I could have made 3 ISSs in the time it took me to make one bag of animal cookies. So I'll put that number here, 3. Now, for Matt, it's similar, but different numbers. It's the only thing that changes. So 4 divided by 16, my opportunity cost for producing a spaceship, is going to be, well, 1/4. So it costs me 1/4 of a bag of animal cookies when I produce one ISS, right? And now, if I produce one bag of animal cookies, it's going to cost me 16 divided by 4 ISSs. So I'll write that right here. So for this problem, Matt has the comparative advantage for ISSs because 1/4 is less than 1/3. And now that means it only costs him 1/4 of a bag of animal cookies to make one ISS, while it costs me 1/3 of a bag of animal cookies to make an ISS, right? So 1/4, that's 0.25, and 1/3 is 0.333, repeating. And so 1/3 is bigger than 1/4 if you need a decimal comparison. But these are whole numbers, so they're a lot easier to compare. And so you can see that I have the comparative advantage in making bags of animal cookies because it only costs me 3 potential ISSs every bag of animal cookies I make? Well, it costs Matt 4 whole ISSs for every bag of cookies that he makes. So, if these two sovereign nations want to trade, what should their terms of trade be? Well, as we already discussed, Matt has the comparative advantage for ISSs, right? So we can circle this right here to signify that. And I have the comparative advantage for bags of animal cookies, so I can circle that. So that means that I should be the one making the animal cookies, and Matt should be the one making the ISSs, right? So what we can see here is this means that's the opportunity cost for producing one ISS, and that's the opportunity cost for producing one bag of cookies. So if Matt's going to make ISSs and I'm going to make animal cookies, then, well, we'll just say in terms of the spaceships, or ISSs, whatever you want to call them, they're the same thing anyway. We could trade one ISS, and that's Matt making that. He could trade that with me for, well, let's say, right here. Say, between a quarter of a bag of cookies and a third of a bag of cookies, and so how you write that is you just say, well, the number I'm going to trade, X, bags of animal cookies, that's, well, it's greater than a fourth, but also less than a third. And what's important to note is it's not greater than or equal to, it is just greater than and less than. There's no equals, because if it equaled 1/4, like if I only traded a fourth of a bag of cookies, well, what's the point, right? Because, see, he's only going to get a fourth of a bag of cookies if he makes it on his own. So why would I give him the same amount that he could just make? But I'm going to want to trade less than a third, because then it's costing me the same amount of cookies, so I could just make the cookies on my own, rather than him giving them to me, or rather me giving them to him. So, one ISS for between a fourth of the bag and a third of the bag of cookies. So bags of animal cookies. Right, and so, for example, an acceptable trade would be, let's say there's 24 cookies in a bag. Well, that'd be between 6 and 8 cookies. So, not 6 cookies and not 8 cookies, let's just say 7 cookies. So in this case, 7 cookies would be acceptable trade. So 1 ISS for 7 whole cookies. Those are some pretty good cookies. And that, in a nutshell, is comparative advantage and absolute advantage for an output problem.
In the next scenario, we will do an example of an input problem. The key difference between an input problem and an output problem is that rather than the factor being how many items can be produced in a set time, we examine the amount of time it takes to produce a set item. In this example, we will be looking at the time it takes to accomplish menial tasks, such as getting the milk out of the refrigerator and pouring said milk into a glass. Here we can see Brennan on his way over to get the milk. Brennan is taking 30 seconds to get the milk here. That's how long is going by right now, is 30 seconds exactly. Here we can see Brennan pouring the milk that he's just retrieved into a glass. Now Brennan takes 120 seconds to pour this milk, even though it does not appear that way. And now here, by contrast, we can see Matt going and retrieving the milk from the refrigerator. Now Matt actually takes longer than Brennan by 6 seconds. Matt takes 36 seconds to retrieve the milk from the refrigerator. So as you can clearly see, this is going to be an input problem, because instead of it being broken up on how many of one thing we can make, it's going to be how long it takes us for us to make one of each thing. Alright? So, as we can see, so the advantage going here is going to be who can do it faster, because that means they can make more of them. So as you can see, for retrieving the milk, Brennan has an absolute advantage because he's able to do it faster than I am, but he also has an advantage absolutely in pouring the milk because he can do it faster than I can do it. But so we're not really interested in that in terms of trading, or I guess assigning pieces in a bakery. We're going to be more concerned with how fast we can do it in comparison to other things we can do. So in order to do this, we're going to determine essentially how many times we could have, for example, retrieved the milk in the time that we had been spent pouring it. So for Brennan, he could have, in the time that it took him to pour the milk, 2 minutes or 120 seconds, he could have retrieved the milk 4 times. So we're going to put a 4 there, and vice versa. He is able to pour the milk only a quarter times as he has spent retrieving it. And then for me, in the time that I have poured the milk, I could have gotten the milk 3.5 times. So as you can see, once we've written down the comparative advantages, things have actually changed. Rather than Brennan having an advantage in pouring the milk because his amount of time is smaller, I actually have a comparative advantage in pouring the milk because my number is smaller here. Likewise, Brennan still has a comparative advantage in retrieving the milk because 1/4 is smaller than 2/7. Alright, so if me and Brennan are going to come to a trade agreement, or if we're going to choose positions at a bakery, then it's important to note the comparative advantage. That's essentially why we do this at all. So because my comparative advantage is lower than Brennan's, then that means that in the time that it takes for me to pour 1 glass of milk, Brennan should have retrieved the milk between 3.5 and 4 times. So what we can write here is that 1 milk pour is going to be equivalent to between 3.5 and 4 milk retrievals. So X is essentially going to be how many times that Brennan is retrieving the milk. It can be anywhere between 3.5 and 4, simply because that's going to be more worth it to both of us for us to abide by this rules. As in, if he does it anything less than 3.5, then I might as well do it myself because it's cheaper for me. Well, cheaper, takes less time. And if he does anything over 4, he might as well just do both things by himself. But that goes both ways, because Brennan has a comparative advantage in retrieving the milk. And what this means is that in the time it takes for Brennan to retrieve the milk just 1 time, I should have poured between 1/4 and 2/7 of a glass of milk. So what we can write here is that 1 milk retrieval is going to be equivalent to between 1/4 and 2/7 of a milk pour. And the same thing goes for this. If I give him anything less than 1/4 of milk, of a glass of milk, he might as well have just done it himself. Likewise, if I give him anything more than 2/7, I might as well be doing it myself. So if we abide by these rules, we should really be saving time in the long run. That is an input problem. Hey guys, thanks for checking out our econ video. We hope you learned a lot about input and output comparative advantages. So my name's Matt.
And I'm Brennan.
And we hope you love econ.
Yeah, we sure do.
Good luck on the test, guys.